For 15 years, the global performance car establishment told the world that continuously adaptive aerodynamics is a halo car luxury engineering too complex to ever reach a mass market price. That was never true. Xiaomi's SU7 Ultra just proved every word of it wrong. The number is 285.0 kilograms. That is how much downforce a rear diffuser generates on a production sedan, tilting through a continuous 0 to 16-degree range, switching between drag reduction and downforce maximizing modes in real time. It costs the buyer nothing extra. It is standard equipment on a car starting at $73,000. Ford's answer to the same physics problem the Mustang GTD costs $325,000 is hand-built in Canada by Multimatic and is capped at 1,700 units for its entire production run. This is not just an engineering story. This is a supply chain story, a job story, a Detroit story. The story Americans were told about active aerodynamics began on the racetrack. Formula One introduced the drag reduction system in 2011, and within a few years, the technology trickled down into road cars first as six-figure hypercar exclusives, like the Bugatti Veyron's adjustable rear wing, then as the calling card of a new generation of halo cars. By the time Ford Performance and Multimatic built the Mustang GTD Active AERO, had become shorthand for engineering seriousness. If a car had it, that car mattered. That confidence was earned. The GTD's F1-style DRS wing and hydraulic front flaps are genuinely sophisticated, and Multimatic's motorsport pedigree is real. Nobody should mistake this story for Ford building something lazy or dishonest. But the entire industry carried one assumption that nobody tested that active AERO and mass production were mutually exclusive by nature, not by choice. Scarcity wasn't a side effect of the engineering, scarcity was the business model. A $325,000 price tag needed 1,700 units to stay believable. Nobody in Detroit, Stuttgart, or Maranello had a reason to ask whether that constraint was real. But while Ford was celebrating its most exclusive Mustang in history, something was already rolling off an assembly line, not in a boutique motorsport shop in Canada, but in a factory in Beijing built to ship 500,000 cars a year. Every aerodynamic surface on a car lives on a single curve. More downforce means more drag, and more drag means a lower top speed. A fixed wing or a fixed diffuser forces an engineer to pick one point on that curve at the design stage. And every driver, in every condition, for the entire life of the car, lives with that one compromise. For decades, that was simply accepted as physics, not as a design choice. A fixed diffuser could not become more aggressive in a corner and then relax on a straight. It was one shape permanently. The SU7 Ultra's rear diffuser breaks that constraint. It tilts continuously through a 0 to 16-degree range and switches between two adaptive modes, one tuned for minimum drag, one tuned for maximum downforce, adjusting in real time to how the car is being driven. The number that matters here is 285.0 kilograms of combined downforce generated by a fixed 1,560 millimeter wing working together with that active diffuser. Picture the same car on a Colorado mountain switchback and then on a flat Texas interstate an hour later. One geometry cannot serve both roads well. This one does not have to choose. Push the same drag versus downforce problem to its most extreme form, a track-focused supercar chasing lap records, and the engineering gets harder. And so does the manufacturing. Ford's solution was the Mustang GTD and F1-style drag reduction system rear wing that opens and closes between two binary states paired with hydraulically actuated front underbody flaps, all assembled by hand at Multimatic's specialty facility in Canada. That is not a criticism of the engineering. It is a statement about what that engineering was allowed to cost. The GTD starts at $325,000. It is capped at 1,700 units for its entire production run. Only 271 were built in all of 2025. An American buyer who wants this specific solution to this specific physics problem does not simply pay a price. They join a list for a car built in low hundreds per year by a specialty motorsport supplier in a country whose entire annual output of this model would not fill a single day's shift at a mainstream assembly plant. Here is the part that should unsettle anyone who assumes price reflects engineering difficulty. A continuously variable system, one that must calculate and hold any angle between 0 and 16 degrees in real time, across two adaptive modes, is a harder control problem than a system with only two states open or closed. Ford's DRS wing is simpler to command precisely because it is binary. Xiaomi's Diffuser is arguably the more demanding piece of control engineering, and it ships as standard equipment at no additional cost on a car priced at roughly $73,000, about a fifth of the GTD's base price. Xiaomi delivered more than 400,000 SU7 vehicles across its lineup in 2025, a figure that includes all trims, not the Ultra specifically. Even accounting for that, the manufacturing scale gap between a Beijing assembly line and a Canadian specialty shop is not measured in units. It is measured in orders of magnitude. Engineering claims eventually meet the only judge that does not care about a press release the stopwatch. The Mustang GTD carries real motorsport credibility. Multimatic's involvement guarantees that. But the SU7 Ultra took its production configuration to the Nürburgring Nordschleife and posted a certified lap of 7 minutes, 4.957 seconds, the fastest lap ever recorded there by a production electric vehicle and the fastest by any road-legal four-door car. That lap time did not come from a car costing $325,000. It came from a car costing a fraction of that with a diffuser system that adjusts itself and a wing that does not move at all. For an American audience that measures credibility in lap times and quarter-mile numbers, this is the least comfortable comparison of the entire video. The price gap between these two cars is not shrinking, the performance gap. In this specific measurement, it is already closed. The Mustang GTD deserves to be judged on its own terms first. It is the most track-capable production Mustang Ford has ever built, an 815 horsepower supercharged 5.2-liter V8, a dual-clutch transaxle mounted at the rear for weight balance, and a semi-active suspension system tuned by Multimatic, the same company that engineers dampers for actual endurance racing programs. Ford did not build a marketing exercise. It built a legitimate performance flagship, and the enthusiast press has treated it as one. Where it is being overtaken is narrow but precise. Not horsepower, not chassis, tuning, not brand credibility. Specifically the aerodynamic control architecture and what it costs to produce. The GTD's rear wing operates in two states, open or closed. The SU7 Ultra's diffuser operates continuously across a 0 to 16 degree range, switching between two adaptive modes, and it does so as base equipment rather than a $325,000 and up halo trim. The performance outcome, a certified Nürburgring lap that beat both the Porsche Taycan Turbo GT Weissach and the Rimac Nevera Time Attack, did not require the six-figure exclusivity that Ford's GTD program depends on. The market consequence is not that GTD buyers will defect. A 1,700 unit production cap was never chasing volume, and Ford knows this. The consequence is structural if continuously variable active AERO becomes an expected feature on $70,000 class performance sedans. Globally, the premium that Ford and the broader American Halo car segment charges for advanced aerodynamics as a standalone value proposition stops being defensible. The next generation of performance buyers will have already experienced adaptive AERO on a car a fraction of the price, and they will ask why Detroit's version costs 4 times as much for a less sophisticated control system. The supply chain question here isn't lithium or cobalt, it's precision actuation and composite manufacturing. Building an active AERO system used to require the same specialty supplier network that motorsport programs rely on low-volume carbon fiber layup shops, hydraulic actuator specialists, calibration engineers who work in batches of dozens, not thousands. That network built its business model on scarcity being structurally necessary. Xiaomi's Diffuser, produced at automotive mass manufacturing scale, is evidence that scarcity was a choice, not a requirement. Tariffs don't fix this. Even where import duties keep a specific Chinese vehicle out of American showrooms, they do nothing to stop European, Korean, or Japanese automakers, all facing lower trade barriers from licensing or independently developing the same continuously variable architecture and undercutting Ford's Halo car pricing without a single Chinese badged car crossing the border. For American specialty suppliers like Multimatic, the business has always depended on OEMs believing advanced AERO requires hand assembly. That belief is now testable and increasingly falsifiable in public. For Ford Performance, the deeper risk is to the R&D model itself. For decades, motorsport-derived technology has trickled down from six-figure Halo cars into mainstream vehicles. If mass-market cars overseas demonstrate the technology first and cheaper, the pipeline runs backward, and the R&D budget that justified GTD's price tag has to answer a harder question than does it work? It has to answer, why does it cost this much? What happens next depends not on tariffs, but on whether American engineering culture can move faster than it has in the last 40 years. Active Aerodynamics is no longer a scarcity-priced Halo feature. It is now a standard equipment expectation proven on a production line built to ship 500,000 cars a year. Detroit's pricing model, the one that justified 6 figures for hand-built exclusivity, just lost one of the arguments it depended on. Nothing here required Ford to fail. The GTD is a real car engineered by real talent validated on a real racetrack. What changed is not Ford's competence. What changed is the world's tolerance for the idea that advanced engineering must be scarce to be real. Multimatic will keep building 1,700 GTDs. Xiaomi will keep building hundreds of thousands of SU7s. Both companies solved the same physics problem. Only one of them solved the manufacturing problem that came with it. The question is not whether Ford can build active aerodynamics. Ford already has. The question is whether it can still charge $325,000 for it, now that the rest of the world has seen what it actually costs to build.